The world is suffering from a sanitary emergency due to the COVID-19 virus. Thanks to the efforts of many laboratories, a vaccine was created in order to solve this problem. Colombia has been affected by this problem. Consequently, the government has agreed on buying vaccines in order to face the threat. By the name of National Plan of Vaccination, Colombia has designed a logistical chain that will take the vaccines to different parts of the country. This plan considers the transportation from ultra-freezing temperatures, minus 20 Celsius degrees, to 7 principal cities of temporal storage, where they will be distributed to other cities in a range between 2 to 8 Celsius degrees. Because of this, Termofilia, as a production company of refrigerating devices for vaccines, assumed the challenge of developing a container that will facilitate the transportation from the city of Medellin to Quibdó, maintaining the required cold chain. Thanks to a hard investigation and taking the necessities from the Sprint 1 as a starting point, all of them were classified like this. These necessities are identified under the assumptions of 1. The vaccines that we will transport are Moderna. 2. The transportation is by air. 3. The container is exposed to the weather of Quibdó. The main characteristics of the container were obtained by the requirements of the user of the container, shown right here. Termofilia used the QFD matrix in which each solution from the Spring 1 was compared with the other existing solutions from the market based on these requirements. Due to all of this, there was an evaluation of the possible competition of the proposed solution. With all of the compiled information of the necessities, user requirements, and the QFD matrix, there was a definition of the engineering characteristics and also the methods that will be used to quantify and define the design range limits. As a clarification, the maximum and minimum from the characteristics of each moles were eliminated. In order to evaluate the effectiveness of the solution concept from the Spring 1, Termofilia designed a series of normalized performance indicators related to engineering characteristics. These indicators conclude that we should continue with the solution 1 to fulfill our objectives. The solution 1 is divided into models that establish which of the elements are going to be bought or designed by Termofilia. In this case, it is seen that the solution concept is divided into modules and the parts that will be bought and designed in the image. In the selection process of the materials, there was a priority of the potential of the insulators of the whole solution. To be more precise, in the selection process, the team performed thermal simulations that will include different layers of insulators, containers, and cool packs. For the container material, the material with the less heat flux and thermal conductivity was chosen. Also, the selection was based on the less transmission rate of water steam in order to avoid the incremental of internal temperature in the system. The same process of criteria was used in the selection of the material for insulator 1. For the second insulator, the same heat flux analysis was realized, which showed that the heat flux was negative. This happens because of the cool pack temperatures. In this part, the rubber and polystyrene were chosen because it was not necessary the use of extremely insulated material. In order to observe the more convenient material for the second insulator, the variation of the vaccine temperatures were analyzed by the simulation of the two materials mentioned before, rubber and polystyrene. This allowed the team to conclude that the time in which the vaccines were in a safe range of temperature was less than the required. Due to this, the team has the intention to redefine the thermal simulation to obtain safer results. In order to select the grips of the container, we have a transport belt. Its principal selection criteria were based on what we see next. Commercially, the cool packs were designed to fulfill refrigerating standards for vaccines. The selection of these devices were mostly influential by the geometry of the internal system. The final characterization of the selection process is shown with each global performance indicator and the compile of the actual design process, as we can see in the chart. Termofilia identified that, first, it is necessary to develop thermal simulations in the software that will allow the team to obtain better results in the gray ridge. Second, the tools were used in the prototype selection process were useful and they will be used in future cases. 3, it is necessary to develop physical prototypes of low cost in order to study a prototype under real conditions. Finally, each of the objectives of Termofilia for the next sprint are shown. Thanks.